All right, so we're back, and now we're going to do 9-2. Okay. The learning target you're going to see here at the top is going to be analyzing and interpreting data displayed in box plots, dot plots, histograms, and two-way frequency tables. So we're going to go through and do an example of each of these so that you can see what they look like. Remind yourself, again, they're probably things you've done when you were younger. And then you are going to take some time to answer some questions about the last ones on your own. Okay. So the first part I want to talk about is the actual shape of the data when you see it on a graph. Okay. There are four different ways that this can look. The first one is called skew right. And I know what you're thinking with the right and the left. They're like backwards, right? So this is skewed right. And this is actually when most of the data points are on the, and this, you guys, this left out, so you need to put this here, on the left side of the graph. Okay. Most of them are on the left side. So it's kind of like opposite, kind of like when we talked about the transformations when it was shifting left and right, and it was always the opposite of what we thought. Okay. Skewed right means the data points are mostly on the left side of the data. Okay. Of the graph, sorry. Then skewed left is when most of the data points are on the right side of the graph. So this part here needs to be marked through, you guys. Looks like my forgot to hit enter there or something. Okay. So skewed right and skewed left. Okay. The bottom two, random distribution, means that there really isn't a pattern to the data. It just kind of goes up and down and does all sorts of things randomly with no set pattern. And normal distribution creates an even distribution on both sides in the middle. So that's that bell curve that I was just talking about earlier in 9-1. So it kind of goes up and then it comes back down gradually. It's not exactly the same on both sides, but it creates that pattern. Okay. To kind of give you an example of each of these in real life, um, if we think about maybe if you're playing the stock market, right? You want to invest your money in the stocks that are doing the best, right? So you might try to skew your data right so that you have your highest stocks coming first, and then you know your low ones that go down as it comes to the list. Okay, so highest value stocks first, right? Then skewed left, meaning that you're going to go up as you go to the right. Maybe something like if you were a coach and you were wanting to make your batting lineup for baseball, right? You would want to know your players' batting averages and you want to know them from least to greatest so that you can figure out who you would want to put in your lineup where. Okay. So I'm just going to put your coach making a batting lineup. Okay. Then down here for random distribution, right? There's no real pattern. So think about maybe like wait times at a restaurant, right? It depends on what time of day. It depends on if there's an event happening somewhere. Maybe the baseball game just let out and now it's really busy at like 3 o'clock in the afternoon. You just never know, right? So this would be like all over the place. So I'm just going to put your wait times at a restaurant. Okay. Then normal distribution, when it creates an even on both sides, would be something like your test scores in a class. You're always going to have most of the people that do about average in the middle. You're going to have some that do a little bit worse and some that do a little bit better, right? Okay, so those are the four types of shapes of data on a graph. Now we're going to go into the actual different kinds, okay? So the first one we're going to talk about is a dot plot. And a dot plot is exactly what it says, right? You are actually putting dots down for the data values, okay? hopefully you know that if this is talking about the minutes to eat breakfast down here, that each one of these dots that you see is representing a person that said it took them that long to eat breakfast. So, for instance, if I wanted to know how many people said they took 3 minutes to eat breakfast, I would look here in this column, and there are 1, 2, 3, 4, 5 dots. So, 5 people said they ate breakfast for 3 minutes. Okay. Um, First question: how many people take 9 minutes to eat breakfast? So again, I'm looking at 9. There are 3 dots there. So that means 3 people said they take 9 minutes to eat. And then the second question is this data evenly distributed? So again, does it make that like nice bell curve, right? And obviously this is not. We're up, we're down, we're up, we're down, we're up, we're down, right? So this would be random. There's no real pattern to any of the data here. Okay? So super simple. Dot plots, plotting a point for each of the ones that match that data point. All right. Two-way frequency table is next. And this is exactly what it means. Two different ways of looking at data and how often it occurs. Okay. So on this side, we have people that like and do not like snowmobiles. And on the top, we have people that like and do not like skateboards. So all people who like skateboards go this way, don't like skateboards in this column. Then same on the other side. Like snowmobiles goes this way, do not like goes this way. So the totals are in pink, that peachish pale color. The blue is where those things overlap for snowmobiles and skateboards. And then this guy in the bottom would be the total amount of people for both of those things. Okay? So the first one up here says what percent of the total number of people surveyed like snowmobiles? Okay, well, again, total number of people would go on the bottom, so that's 160. That's where we got this. And they have to like snowmobiles. So here's my like snowmobiles, goes right across here, and the total that likes them is 105. So to get a percent, you need to take 105 divided by 160, just like you do when you're figuring your grade for your test, and you get 0.656, and then a couple more numbers, right? So this 6 would tell us to go up. So this gives us about 66% of people that were surveyed like snowmobiles. All right. So then same thing down here, kind of writing all over my chart here. If you're looking for the percent of the total number of people who like skateboards that do not like snowboards or snowmobiles, right? So the total number of people who like skateboards, well, that's this column, and the total of that is 125. So that would be your bottom number. And they do not like snowmobiles. Okay, well, in this column, 45 people don't like snowmobiles. So 45 goes over 125. We divide those, and we get 0.36, which we transfer over to a percent, 1, 2, 36%. Okay? Two-way frequency table showing you two sets of data and how they overlap with each other. Okay, moving right along, we've got a histogram. A histogram is a lot like a bar graph, only what you're seeing is actual like categories of data down here, right? You're not just seeing one number, it's like a range of data. So this is hours of sleep each day in a 24-hour period. So hours of sleep would be down here, and how often it occurs is the bar. So how many people actually said that they sleep that amount of time? Okay. So using the graph, how many people get between 3 and 5 hours of sleep per day? So if we look down here, this is going to be more like a range, right? So from 3 to 5, we've got 2 people in this one, 2 people in this one, and 4 more here. So if I add those together, I would have about 8 people. We can't get an exact estimate because this is a range and we don't know exactly where 5 stops. Okay. So same thing on the next question. It says how many people get between 9 and 10 hours of sleep. And again, this down here is going to tell you that we have 14 and 2, so about 16 people. Okay. Next question. Is this data normally distributed? Okay, so does it make a nice curve we were talking about? And yeah, it does. It goes up pretty steep, but then it comes right back down, right? So that would be yes. It's evenly distributed. Okay. All right. Save the best one for last. The box and whisker plot. Okay. Um, so for this one, you're seeing it given to you up and down vertically. Normally, when you see a box and whisker plot, it looks like this. It will be horizontal. Okay. And we're just going to kind of talk about the parts and how you read it. Okay. So box and whisker is made up of 4 different sections. It will look like this every time. The line in the middle will be different depending on how much data, and the little whiskers will be different depending on the data as well. Okay, so 4 different sections. This would be like your first one, right? On the left, here's 2, here's 3, and here's 4. Okay, so each one of those sections represents 25% of the data. So I'm just going to go in here and put this is 25%. Then this one would be 25%, and so would the other one. So this is 25, this is another 25, and this is another 25%, which means that altogether it would equal 100%. Okay. Another important aspect of this is that this guy in the middle is the median of the data. Okay. So it's the middle of the data. And it doesn't have to be in the middle of the box. It's just where it lies as far as a number. Okay. Because we all know that the median doesn't have to be the actual middle part of those values. Okay. Then this guy on the end down here would be the lowest value that you have in your set, which means this guy on this end would be the highest value that you have. Okay. Last thing, because this is broken up into sections of 4, okay, they're called quarters. And this middle 2 quarters is called the IQR, the inner quartile range. Okay? So inner quartile means just those inner, the inside, so the 2 boxes, and the range from how far it is from here to here. Okay? Range meaning the biggest and lowest values of that section of the graph. Okay? Lots of vocab there, so make sure you study that. So, first one says, what percent of ice cream bars have between 439 and 221.5 calories? So, 439 is here, 221 is here. So, that gives you this section and this section. So, if they're each 25%, that means 50% of the data is between those two. Okay. Then, if we look at the next question, it says, what percent of ice cream bars have between 319 and 111 calories? Okay, so now we're here, and 111 is down here. And we've got this section, and this section. So if they're each 25% together, it's 75% of the data. Okay? So just keeping all those values in mind and all the things, parts of the box and whisker are the most important. All right? Now, please pause the video and go try the rest of these on your own. Come back and check it. Okay? Okay. If you're back for the check, this is a histogram. So it's giving you again these ranges down here on the bottom, right? Instead of it being just one number, it's a whole range of numbers. And this is how often it's happening. Okay, so number of presidents and their age of inauguration. So, what is the most common age of a president at the time of inauguration? Well, that would be this tallest column here. So that would be from ages 55 to 58 years old. Oops. 58. There we go. Um, what type of distribution is this histogram? Now that would mean left skewed, right skewed, normal, or random. Okay. Well, this one's pretty normal. It goes up and then it comes back down. There's a little bit of dip here and dip here, but we're not going to worry too much about that. Okay. So this is pretty normal curve. Then how many presidents were over the age of 62 at the time of their inauguration? So over 62 would be both of these at the end. This one is 1 and this one is 2. So that means 3 were over the age of 62. Okay, moving on. Box plots, talking about the number of shoes people have. What shape is the distribution? Okay, well, this one goes up and then down and then up and then down and then up. So I would say this one's pretty random. Possibly a little bit, maybe right skewed if you look, because most of our data is happening over here on that first part, which is the left side. So remember, it could be, or it's always the opposite. So I would say a little bit right skewed as well. I would take both of those. Okay, what is the range of the data? So if we're talking about range, we would have the lowest and the highest value, right? So 16 minus 8 is 8. Okay. How many students were asked the number of shoes that they own? Well, how many students is talking about being able to count the dots? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're talking about 16. Oops, that goes in another one. Sorry. Oh, I'm having trouble with my eraser. There we go. 16. Okay. Then what is the mode of the data? So which one of these has the most dots? And that would be 10, right? So the number that was said the most for numbers of pairs of shoes would be 10. I'm guessing that most of you have way more than 10 pairs of shoes. I know that I sure do. Okay, so two-way frequency table is next. And again, remember, this is talking about two different parts of data. So talking about owning a car and having a driver's license. All right. What percentage of students who have their driver's license? Okay, let's stop there. Who have their driver's license. So driver's license, yes, all the way down. 67 kids have it. Okay. Also have a car. So in this group of data, these students have a car. So 43 out of 67 is 0.641. So about 64%. Okay, which is makes sense, right? If you're going to have your license, you might as well have a car. Are students more likely to have a car if they have their driver's license? Well, that's that same column, right? So if they have a driver's license, they're 67. Yes for cars is 43. No for cars is 24. So yeah, they are. more likely to have a car if they have their license. Okay, last one, and then you're done. Box and whisker plot. So for this one, again, remember, it's talking about the quartiles, right? So 25, 50, 75, 100%. Okay. And we're comparing varsity and JV varsity or junior varsity. So, what percentage of JV scores are below the median of the varsity? Okay. So, the median of the varsity is this middle bar here, right? So, how many of these scores are below that? Well, the whole thing is. So, 100% of the scores are below the median of the varsity. Okay. Erase that so that I can make more. All right. Next one. The lowest scoring varsity player. Okay. Stop and think. Lowest scoring varsity player is right here. He is better, or she is better than what percent of the JV team? Okay, well, it's higher than this portion right here, right? Which is 25%. Okay, last one. What percentage of varsity players scored between 46 and 55? Okay, well, again, 46 is here, right? 55 is here. So percentage-wise, is that inner quartile range, which would be 50%. All right, hope you did well. Again, you guys should be working on your homework for 9-1 and 9-2. And if you don't finish it, you can always finish it on Friday when you come back to class. Okay? Enjoy your spring break. Hope these all make sense, and I'll see you back next Monday.